All right, so let's start looking at this transformation idea on a graphic level. Ooh, maybe we should put a PG-14 rating on this because of its graphic nature. Anyways, moving right along. Okay, so we've got a function here. We know it's going to be a square root function. You know what? Probably the best thing in the world to do right now is let's actually go out and graph a square root function, and then we'll look at it from there. Think about it. Square root function. Think of a table of values. Start with x being 0. Now, notice that I didn't go into the negatives because you can't take a square root of a negative. So I'm going to start right at 0. Square root of 0 is 0. So there's our first little dot. Beautiful. Let's go to 1. 1, square root of 1 is 1. There's our next dot. Now, start thinking about numbers that are square rootable. Well, 2's not square rootable. 3's not square rootable. 4 square rootable. Square root of 4, there's 2. Okay, next square rootable number, think of your perfect squares. It's got to be 9. Square root of 9 is 3, and there's what your original graph is going to kind of look like. It's kind of got this curve to it like this. Oh, how pretty is that? All right, now, with that idea, let's now take a look at this guy here. Let's look at g of x and let's see what we can do. Uh-oh, I see something. Do you see it? There's an issue there. We have to factor out the 3 because there's no bracket here in front. Aha! So let's do exactly that. Let's erase this. Let's deal with that guy first. So 3x minus 12, we're going to factor out the 3. That becomes 3x minus 4. Now that looks right. So we've got a b value happening here. We've got an h value here, all in the horizontal. Let's see what happens. So this new transformation is going to look like this, or this new value is going to look like this. It's going to be minus 2. There we go. Square root of 3x minus 4 plus 5. Now, let's figure out what everything is. First things first. Okay, the a value is negative 2. What does that mean? Well, we're going to get stretched vertically and we're going to get flipped vertically. We've got a b value here of 3, so in fact, we're actually going to be using 1/3. We have an h value, a movement right and left. In this case, it's a movement right of 4. And we've got a k value, which means we're going to move up 5. Interesting. Okay, let's go. Here we go. Now, we could take this and we can go point by point and try to keep all of these things in our head organized, or we can actually just make a little table of values. Why don't we do that? Why don't we make just a small little table of value of all of the transformations that we're going to do? So here's the original x's. Oh, I'll do this in green so it matches our graph. Okay, wait a second. Hold on. Here's our original x's, okay, which were 0, 1, 4, and 9. Here's our original y's, which were 0, 1, 2, and 3. Perfect. Now, we're going to transform these guys. So how do we transform? Well, think about it. Maybe we should actually develop a mapping for this. That's going to be really, really cool. And that's one of the reasons why I put it down here. We're going to use this mapping notation. We know what the mapping notation is. It's all of this stuff here. Let's just plug in the numbers. Why don't we? Okay, so every point, this x and this y become, every point x, y becomes, well, there's your b value, 1/3 x, right, plus h. Okay, where's h? Oh, there's 4 plus 4. Beautiful. Let's do the same thing for the y values. This is going to be negative 2 times whatever the y value is, y coordinate is, plus 5. So every point is going to have that transformation applied to it. Okay, so the hardest thing then is to kind of keep this thing all organized. Okay, so let's call this our new graph, which of course is going to be our g of x graph. Okay, so here we go. Let's apply this. Ready? To 0. First thing, 0 times 1/3. Well, that's easy. That's 0 plus 4. Yeah, there's 4. Let's go to the y value. 0 times negative 2 is 0 plus 5. There's 5. Does that not make sense, though? Does that not make sense? Because after all, it's moving this 4 right, 5 up. So we can do that right on the graph right now. We're going to go 4 to the right. 1, Here, take this guy. 1, 2, 3, 4, and 5 up. 1, 2, 3, 4, right there. There's our new point. There's our new starting point. That point becomes this point here, transformed. Ah, interesting. Okay, let's keep right on going. All right, so we've done the first one. Let's go to 1, 1. This becomes a little bit more complicated because after all, you're now dealing with an ugly fraction. So what? If you're not comfortable with fractions, pull out your calculator and do it that way. But I'm pretty comfortable with fractions. So let's go. 1 times a third is 1/3 plus 4. This is now 4 and 1/3. Oh, so just slightly over 4. Great. Let's do the same thing to this one. Minus 2 times 1 is minus 2, plus 5 is 3. Okay, so there's my new point. I'm going to go 4 and 1/3, 3. So there's 4 and 1/3 is about here, and 3. Oh, okay, so there's my new point right there. I'm going to make it nice and big so that you can see it. Okay, and then let's keep on going. Let's go to 4, 2. Okay, 4 times a third is 4 and 1/3. Okay, plus 4, right? 4 times a third is, well, wait, no, sorry, that's 4/3. Oops, that's 4/3. 4/3 plus 4. Now think, what is 4/3? 4/3 is 1 and a third. 1 and a third plus 4 is 5/3. Again, if you're not comfortable, throw that in your calculator. So we're looking at 5/3 here. So this guy here, and I'm just going to clean it up so that you can see it. Unfortunately, my eraser is so huge, it ends up wiping out a whole bunch of things. Okay, so let's try that again. Put the 4 in here. Okay, 4 times a third is 4/3. So that's 1 and a third plus 4. That gives you 5 and a third. Beautiful. Okay, throw in the y value. Minus 2 times 2 is minus 4 plus 1. Or plus 5 is 1. Okay, so minus 2 times 2 is minus 4 plus 5 is 1. So 5 and 1/3 and 1. That's right around there. So far we got this point, this point, this point. So you can see that it is starting to reflect. You can actually see that kind of graph developing now. Let's do the last point. Okay, well, that's easy. That's 9. Third of 9 is 3. 3 plus 4 is 7. So our new point is 7. And then let's go to this one. 3 times -2 is -6 plus 5 is going to be -1. So our new point is 7, -1. 7, -1, which is right about there. Oh my, look, there's our graph. Oh, look at that. And in fact, it does look like it's stretched vertically. It is obviously reflected. Okay, so you have some really cool stuff happening here. Okay, let's see if there's any other questions that we have to go along with here. Oh, sure, domain and range. Let's figure out the domain and range of our new function, g of x. So obviously, we're starting now on 4. So in terms of our domain, we can say all the values of x such that all the values of x have to be greater because after all, it is going in the greater x direction. So greater than or equal to R4. And of course, x is an element of R, the real numbers. Now, let's take a look at our range. Because now, remember, our range has been flipped. So y such that we start at the 5 here and we go downwards. So y has to be less than or equal to 5. And of course, y is an element of R. So what a really cool way of doing this. And I think the thing that saved us the most is understanding how to do mappings and relating this all to the mapping of this equation. Okay? And that's what we did right there. Wow! What a cool equation and cool graph.